Okay, so this is a very particular chapter where our data have to be naturally paired. So let's just talk about what it means to have paired data, okay? So these would be randomly assigned pairs. I don't necessarily mean that the people are unrelated. They actually have to be naturally paired, but I mean that we randomly choose them from our population. The data are paired, not independent, right? So these two groups are not independent from one another. They're in fact related. So in this case, we only look at the differences. So we will literally subtract lists. Okay? So in a paired t-test, this is no different than choosing a regular t-test on the calculator, but it is on list 3, which we set equal to list 1 minus list 2. So this is a very different setup here. So let me kind of walk you through this since I'm not there to walk you through a calculator example. And then if we need to, I'll record a calculator example for myself here. So this is going to be pair. This is like person 1, right? Let's just say they're people. Person 2. I don't know why I had to make that line so long. Person 2. And then we put these people's data in list 1, these people's data in list 2. They are a pair, right? So they must be in order by pairs. Remember, L1's person 1 has to match L2's person 1 on their list, okay? And then, or maybe this is like classic before. This is one way we could do it. And after, so it's not necessarily person 1, person 2, but what if I'm asking the same person and I'm interviewing them before and after? It's possible. But here are our differences. So we actually make our calculator do this work for us. We do L1 minus L2. And what you do is you actually type it into the top box on the list. So watch the calculator videos under learning materials to help you with this. Calculator videos will help here. Okay, this is the only time where I really think you should take a look at that if you're struggling, because we actually don't want you to sit here and find differences on your own. I want you to use the calculator to do it. And then the deal is we run a t-test on this list of data, assuming the difference between the groups is 0, right? They are the same value in each list, right? So remember that if the difference is 0 from our previous chapter, that actually meant that group 1 was the same as group 2. So that would mean that the first person here is the same as the second person. So a paired t-test has different hypotheses than two-sample t-test. We use this type of language. Mu d equals 0, right? So the difference, it's actually not the difference of the means. It's the mean of the differences equals 0. We actually find the mean of list 3, the differences. So we're claiming that that's equal to 0. And then in our alternative, we choose whether we believe that's in fact greater than 0, less than 0, or just not equal to 0. And remember, these are the same 3 options, right? So the first one says that list 1 is greater than list 2, because when we subtract, we'd get a positive number. Then this one says list 1 is less than list 2, and the last one is just telling me that the two groups, or the two lists that I calculated, are not the same. Okay, let's just go to one more slide here. And we're going to keep moving, because we would literally go to our calculator and you would run a t-test. Do you hear Dexter and his toy? Sorry, guys. On L3 equals L1 minus L2. So this is a t-test on data. There is absolutely no choice. You use L3 and you set mu naught equal to 0. And then you choose your alternative hypothesis direction. And the output here is a t-score and a p-value. So you make a conclusion. So I have one choice here. If my p-value, that's terrible. P-value. Dexter, really? He doesn't like when I'm talking to what looks like myself, and I'm not talking to him. He thinks I'm going crazy. If the p-value is less than the alpha level, then we reject the null, and there is evidence of a change. And remember, that change is either greater, less than, or not equal to. And then if the p-value is greater than or equal to the alpha level, so if we have a large p-value, we would fail to reject the null. So there is no evidence of change. There is not evidence of change. Okay, and then finally, I like to talk about our 3 conditions, which I always like to try to go in the same order, but these are just different. So I'll just list them out. The required conditions. I'll start with the normal one. Independence, randomization. And remember, we actually need the data to be related, but we want the pairs / differences to be independent. So we still need random selection. Okay, we're still looking for that. Okay, second condition, paired data. So we literally have to confirm that the data are provided in pairs. And then the third step here, in terms of being able to either make a t-interval on this data or run a t-test, the third condition here is a normal, nearly normal. Maybe I should have switched the order here for you, right? But you check the histogram of the differences to see that it's unimodal and symmetric. Okay, so that would be it. And then I'm just going to make one little note up here that if we wanted to, it would be identical information we would put in the calculator. The t-test here could also be, if we needed to, a t-interval on list 3 equals L1 minus L2, right? We can always find the associated confidence interval by using the exact same test on the exact same data. All right, guys, you're so close. Only one more chapter to go, and then we're done. Keep on working.